We're going to start with section 1.1, which is called Mathematics and Problem Solving. And as we get started, I want to talk about, it's called Polya's. He's the guy who was actually credited for writing it down. Polya's problem solving strategy. And it's a 4-step strategy. Some of it will be mental. We won't actually write down the 4 steps, and parts of it we will write things down, okay? So to start with, the first step is to understand the problem. So some sort of questions to ask yourself as you are trying to understand the problem is, can you state the problem differently? What is it that you have to find? What is it you need to find it? What are the unknowns? What information is obtained from the information? Like, what is in the problem? What do they give you? What information, do you have it, Caitlin? The paper?
Yes,
okay, good. You were looking around like maybe you didn't. What information, if any, is missing or not needed? So oftentimes in mathematics problems in a textbook, they don't try and give you extra information, but in real life, you usually have lots of extra information that you have to sort through to decide, what do I need to make sense of the actual situation? So that's a real practical thing that happens a lot. The second step is to then devise a plan. How are you going to solve the problem? The following is a non-exhaustive list of strategies. Okay, so this isn't like all the strategies that exist, but there are some strategies in here that are useful, and we're going to do some examples of these different strategies. So perhaps you look for a pattern in what's going on. Maybe you have to examine related problems. You've done that before. You go back in the textbook and you look for a problem that looks a lot like the one you're doing, right? You're examining a related problem. Examine a simpler or a special case. Also quite useful. Take a problem that's really big and make it like it's really small, and then figure out how to generalize that to something bigger. It's a very useful strategy. Tables and lists. How many of you are list makers? A lot of them here. I am too. I really like lists. So I'm probably not the only one, but I'm the kind of person who makes the to-do list, and then if I do something that's not on the to-do list, I add it to the to-do list just so that I can mark it off. I got some nodding of the heads. There we go. Yeah. I want to have something to mark off on my to-do list. I like lists. Lists, for me, organize my information really well. So I like that strategy. Identify a sub-goal. So maybe there's somewhere that if I can just get to this point, I know how to finish the problem from there. So then the strategy automatically becomes simpler because I only have to get to the sub-goal. I know what to do after that. Diagrams. I'm not much of an artist, but sometimes visualizing it, even if it's drawing a terrible picture, can be very, very useful. Can take a problem that's pretty complicated and make it very, very simple. And I've got an example to show you of that. Guess and check. A lot of people feel like guess and check, or sometimes called trial and error, is sort of like this taboo. You can't do it. That's not really a very, mathematical approach. But oftentimes, it's not a bad approach. Guess and check, giving something but the important part is the check part, not just the random guessing. That's not especially helpful. But guessing a solution, trying a solution, and then seeing if you can better the idea that you had in mind to find a better solution. Working backwards. I know you've all worked backwards as well. You've all had the experience where you flip to the back of the book and you figure out what the answer is, right? And then you try to figure out, well, how did they get there, right? We work backwards a lot. And so working backwards can be a very viable strategy. Writing an equation. This is one we're not going to talk about. It's mentioned here because it is a useful strategy. But for most of the kids, until you end up in middle school, equations are really not what we're trying to get them to do, right? So even if you think, I know how to do this with an equation, you're probably not going to tell the 3rd-year-old, let's use some X's and Y's, right? But it is a problem-solving strategy that's very useful, just probably not for the age of kids we're talking about. Hang on.